A lesson on linear inequalities. Let us first take a look at some examples of numerical inequalities. The number 3 is greater than 2. 5 minus 2, which is 3, is smaller than 3 plus 4, which is 7, because 3 is less than 7. And the root of 3 is smaller than the root of 5. 2 cubed, which is 8, is less than 25, which is 5 squared. Minus 3, or negative 3, which is further to the left, is smaller than negative 1. And 3/5 is less than 7/8. We can know this if we make the same denominator. We will have 24 over 40, and this is 35 over 40. So 24 over 40 is less than 35 over 40. We next take a look at algebraic inequalities. X is greater or equal to 2. Now that depends on what x is. If x is an integer, then the possibility could be 2, 3, 4, and so on. When we have greater or equal, then 2 is also included. Similarly here, when x is smaller or equal to 5, then it could be even inclusive of the negative numbers, like negative 2, negative 1, 0, 1, 2, 3, 4, and inclusive of 5. Okay, that is if x is an integer. Now here x is smaller than negative 1 or less than. When it is less than, then it is exclusive of negative 1. So negative 1 is not in the set. So it has to be negative 2, and negative 3, and negative 4 onwards. Right, here x is greater than half. Now half is not an integer. So if we are going to include other numbers, if we have rational numbers, then it is limitless. That means it could be 1/3. It could be 1.5. Right, there is many possibilities. It could be even decimal, 3.5, and so on. It could be any number as long as it's greater than half. Now, because there are many possibilities, it is good to represent it using a number line. Let us take a look at these examples. Now, as we can see earlier on, that when it is greater and equal to 2, then 2 is inclusive. So we use a shaded dot. And is greater, so we have a straight line. with an arrowhead. This is to show that it continues with a lot of numbers, like what we have seen before, 3, 4, 5, 6, and so on, is limitless. There's no limit to it. Okay, this is how we represent for greater and equal. The shaded dot means that it's equal to this number as well. So similarly here is less than or equal to 5. Okay, so 5 is included. And then this time we draw the arrow to the left. So 5 is inclusive, the shaded dot. Now if we have less than -1, in this case here, -1 is not included, so we use an empty circle, and it's less than, so the arrow points to the left. Okay, so when it's less than or more than, then that number is not inclusive, so we have to draw an empty circle. In the last example, we have a fractional case. Now, the number line only consists of whole numbers in running order, so therefore, in order to represent a fraction, we just estimate the position. In this case, half is not inclusive, so it's an empty circle, and it's greater than, so it goes to the right. And because the fraction is not shown here, we need to write it either next to the circle. This is how we represent a fractional or decimal case. Now let us take a look at how we solve inequalities. We first look at numerical examples. Suppose we have the numbers 5 greater than 3. Now if we add a number, let's say 1. So if I have 5 plus 1, 5 plus 1 is 6. Right, 5 plus 1 is 6. And 6 is still greater than 3 plus 1. So if we add to both sides, the inequality is still true. So there's no change. Similarly, if we subtract 1, from both sides, we have 4 greater than 2. It is still true. And if we multiply by a positive number, let's say 2, multiply by 2, it will still be greater, because 10 is greater than 6. And if we divide by a positive number, let's say 5, okay, so if we divide by 5 on both sides, then this is 1 is greater than 3/5. Now these rules are similar to that of an equation. However, if we look at multiplying by a negative, let's say I multiply by negative 2, right? So 5 times negative 2 and 3 times negative 2. Now here we notice that when we multiply, we have a negative 10, and we know that negative 10 is more to the left. So now negative 10 is actually smaller than negative 6. Notice that when we multiply by a negative number, the inequality sign is reversed. So let us take a look at what happens when we divide by a negative. Say we divide by negative 5, and on this side 3 divided by negative 5, and we know that the result negative 1 is less than negative 5, right? Because negative 1 is more to the left. That means solving inequalities, it works like equation, except for the fact that when we multiply by a negative or divide by a negative, we have to reverse the inequality sign. Let us now look at some examples of solving algebraic inequalities following the rules of equation, except for the fact that when we multiply or divide by a negative. So here we subtract 3 on both sides. Everything looks the same, no change of the inequality sign. So we subtract 3, we left with 2, divide by 2, there is a positive number, so no change of sign, and the result is greater than or equals to 1. Here, first we get rid of the 2, we subtract 2. Subtract 2 is 6 plus 2x. And we want the x to be on this side, so we subtract 2x. Subtract 2x leaves us with 6. Subtract 2x will give us negative 3x. And now we are dividing by a negative number. Divide by negative 3, and we need to reverse the sign. Divide by negative 3 will be negative 2. In the last example, we have a fraction. Now we can cross multiply, but we have to be careful here. We should keep the x term on the left, because we cannot just move it over, or else it will be affected by the sign. Right? So we cross multiply first, keeping the x term where it is on the left. Right? So we expand it out. And now we have negative 6x is then 8. So divide by negative, so we need to reverse. That is negative 1 and 1/3. The answer must be a mixed number. Now, let us take a look at how we solve problems in inequalities. Tom uses 8 liters of petrol every day. But at the start of the journey, he topped up with 100 liters. Given that there must be at least 15 liters in the tank at all times, form an inequality. Okay, so we let x be the number of days he can travel. Alright, so now x is the number of days, then 8x will be the total petrol that he used for that number of days. And we know that this has to be less than 100 because he tops up only 100 liters. So whatever he used up will be 8x. And this has to be at least. Now, what is the meaning of at least? At least means 15 is included and more than 15. That is the meaning of at least. Right? 15 or more, that is. Okay, so solving this. (15) minus 100 is negative 85. And now divide by a negative, so we need to reverse the sign. Right, this one is 10 and 5/8. Now, so the number of days, right, the maximum number of days he can travel before topping up again. So a day should be a whole number, is 10 days. And the last example, we have Mary has 25 coins consisting of 50 cents and 20-cent coins. So we have 25 coins and we have 50-cent coins and 20-cent coins. And we don't know how many 50-cent coins. We let it be X. Then the number of 20-cent coins will be 25 minus X. And the total for the 50-cent coins is 50 times X. And the total for 20-cent coins is 20 times 25 minus X. So this gives us the total value of the 50 cents and 20 cents. And it has to be less than $8. Well, since it's all in cents, $8 must also be in cents, which is 800 cents. Right, now we solve this. 50x plus 500 minus 20x is less than 800. And this gives us 30x is less than 300. And x is less than 10. Okay, so therefore x is the number of 50-cent coins and it is less than 10, therefore the maximum you can have is 9. And this concludes the lesson on inequality.